2.3 definitions, I'm going to talk about bar graphs, time series graphs, pie charts, dot plots, and then in red I have stem and leaf plots. I'm going to do a second video after this one as far as that goes. Now, bar graphs are exactly like histograms, except instead of the data being continuous, the data is categorical. So I could make a bar chart like this one, and the heights of each of my bars are going to be the amount, and on my x-axis, I'm going to label it as, I don't know, red, blue, green. That's categorical data. Now, the book makes a big deal of the fact that you can also do this sideways, so it's shooting out of the y-axis and not just the x-axis, but really it's the same notion. You have categorical data and you're just counting it. Now, very similar to the bar graph is the dot plot, which kind of looks like your tallies, where you have an x-axis where you have your list of things. So we'll go with, again, red, blue, and green, just like I had labeled everything else. And now you're keeping little dots as your tallies. You could do the same thing if it was a class list. It's just like your tallies. There's no big deal. You're just using a dot, and notice how it's equally spaced so that everything will measure up. Now, when we talk about time series graphs, guess what the x-axis or the y-axis, depending how you label it, needs to be? It needs to be dealing with time! Yay! So don't be tripped out about that. And a lot of things in the real world are measured in time. This year's data versus next year's data, or this month to the next month to the month after that. It's just called a time series graph because you're interested in time as your explanatory variable. Alright, last up for this video, we're going to talk about pie charts, which you've all seen before, so it's nothing special. We make a circle, and then we make wedges in our circle, so it looks like slices of pie. Now, how many degrees are in a circle when you start at one place and you swirl around the other? Yeah, 360 degrees. So if you take those 360 degrees and you multiply it by your percent, you're going to get, I'm going to call it theta from geometry. You're going to get the angle that each wedge is for the percentage of the overall. Now, the pie chart is good when you have 100% of something, 100% of sales, and you're breaking it up into each category. So I could take this categorical data for my box plots or my dot plots. The total number would be on the bottom. The portion that it is would be the top, and I'd get my percent, right, part over whole. Multiply that by 360, and I get what each of these angles is going to be. So what I did is I circled in green my theta, and that's what this portion of my pie chart would be, the one that I'm gesturing to in the circle. Again, read the book if you're confused by this at all, but really it's simple concepts we've seen before. Next video I'm going to talk about stem and leaf because it's a little different.